Welcome everyone to this session. In this session, we will have examples based on probabilities. Let's see this first example. Write the sample space for a rolling die. We all know a dice. Alright, we have to find out the sample space for this experiment. The experiment is rolling a dice. Whenever we roll a dice, the number which occurs on the topmost is one of the possibilities. There are total 6 numbers on the dice. So the total number of possible outcomes will be 6. That is the number appearing on the dice, which is 1, 2, 3, 4, 5 and 6. All the number of possible outcomes is your sample space for that particular experiment. Similarly, when we come to the second example, write the sample space for rolling 2 dice. Here, the experiment is rolling 2 dice at once. So whenever I am rolling 2 dice, this is my dice number 1 and this is my dice number 2. We have to find out sample space. Sample space would be if on the first die I have number 1 and on the second die I get number 2. So one of the possibilities 1, 2. Similarly, there is one more possibility which is 2 and 3. So the another possibility is 2, 3. Similarly, we have all the possibilities at 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6 and so on and so forth for each and every element, which means each and every element will be combined with the other element. And hence if we count down, the number of the sample space would be 36. So in numerator we have 7 and in the denominator we have 12, that is the total number of bags, total number of balls in the bag, which is the red ball equal to 8. Total red balls are 8. Similarly, total blue balls we have 7 and green balls as 6. So the total number of balls in the box would be all the colored balls, which is the red balls, blue balls as well as the green balls. Addition of all of them. So that is 21 balls we have into the box. Now what are they asking is one ball is picked up randomly. Out of these 21 balls, we are picking up one ball randomly. And we have to find the probability that the ball which we have picked is neither red nor green. Now what do we mean by ball is neither red nor green? Out of the 3 colors, if the ball is not red, not green, which means the possibility would be the last colored ball remaining colored, which is the blue ball. The ball which is neither red nor green would be a blue ball. So what we have to find out? We have to actually find out the probability of getting a blue ball. This is my event. So in the formula, it would be number of blue balls in the bag divided by the total number of balls in a bag. Blue balls is 7 divided by 21. Reduce it, which is 1 by 3. Now let's see this example. There are 5 green balls and 7 red balls. Whenever you're writing the answers, always write down whatever the given data that you have in the question. So that is the number of red balls equal to 5. Sorry, there is one mistake. Number of red balls and okay. So the number of red balls is 5 and the number of green balls is equal to 7. Now, two balls are selected one by one without replacement. Now what we are supposed to be doing, out of the total balls will be what? Red balls plus green balls, which is equal to 12. So out of this 12 balls, what we are doing is we are taking out two balls one by one without replacement. Now this is very important, the word without replacement. What do we mean by without replacement? Which means if I'm picking the first ball out of these 12 balls, out of the 12 ball, I'm picking one ball and I'm keeping it aside. I am not putting it back into the box. So when I am picking up the second ball, how many possibilities do we have? Because one ball is already taken out. We are not keeping it again into the box. So that would be 12 minus 1, which is 11. So when I'm taking the second ball, we will have only 11 total balls available into the box. Yes, is that clear? Now let's see what are they asking us. Find the probability that first is a red ball and second is a green ball. They are talking about finding the probability about two events. The first, that the first ball where we are picking up has to be a red ball, and the second that we are picking up has to be a green ball. Now there is one word between both the events, which is and. Whenever there is this word and between any two events, which means here we can apply the multiplication rule. Multiplication rule says that you can multiply the probabilities of the first event and the second event. So we will separately first find out the probability of the first event as well as the second event, and then we will multiply both of them. So what is your first event? That the ball is red. Probability of getting a red ball. So that would be number of red balls in the bag divided by the total number of balls in the bag. Number of red balls we have 5 divided by 12. When I'm picking the first ball, I have all balls available with me, which means total number of balls. So 12. My sample space would be 12. So this probability would be 5 by 12. Now, when we are moving here, probability of getting a green ball is equal to number of green balls in the bag divided by the total number of balls in the bag. Here, we are picking the second ball. So when we are picking the second balls, our sample space would be 11. Why? Because in the question, we have a word called as without replacement, which means the first red ball that we are picking, we are not keeping it again into the box. We are keeping it outside of the box. So in the box, we have only 11 balls. Earlier there were 12. One box is removed outside, so minus 1 would be 11. Hence, while finding the probability of the green ball, which is the second one, our sample space would be 11. And the number of green balls is 7. That won't change. Divided by 11. Now by multiplication rule, probability that the first is red and second is green is equal to multiply both of them. Why? Because there is a word called as and in both the event. Whenever they call about and, then we use the multiplication rule. So probability of the first event 5 by 12 into 7 by 11, which is 35 by 132. Remember this one thing always, when to use the multiplication rule. Whenever there are two events given to us in the question, whenever they are asking about finding the probability of first event and the second event, what we have to do by multiplication rule, find out the probability of first event and second event and multiply both of them together. But in any cases, if there is a word or given to us instead of and, if we have or, first event or the second event, in this case we will not use the multiplication rule, we will use the addition rule. Know the difference between multiplication rule as well as the addition rule. We have example based on addition rule in the further examples also, so we will see that. But remember this one thing, whenever the and word is used, two events are given and words is used between them, then it is multiplication rule. And whenever there is the word or, then we have to use the addition rule, which means we have to add both the probabilities. Let's look into this example. Find the probability that a leap year has 52 Sundays. Now, what is a leap year first of all? A leap year is a year plus one extra day, that is 29th of February. If you remember, most of the times in February we have 28 days only, but in a leap year we have one extra day, which is 29th of February. Leap year occurs after every 4 years. All right. So in leap year we would have 366 days. In normally we would have 365 days, but in leap year we have one more extra day, so that is 366. Okay, is that clear to everyone about the leap year now? So what they are asking us about is, find the probability that a leap year has 52 Sundays. Now there is one thing, which is any leap year can have 52 Sundays or 53 Sundays. But we have to find out the probability for 52 Sundays. Just now we have seen that in the leap year there are total 366 days, in which there are 52 complete weeks. Complete weeks as in Monday to Sunday. This is my one complete week, all 7 days in 1 week. So that is my complete week. 52 complete weeks, and we have 2 remaining days. These 2 remaining days could be anything. It could be Monday, Tuesday, Tuesday, Wednesday, Thursday, Friday, Friday, Saturday, could be anything. There are total 7 days, right? So here if you see, we have 2 possibilities. There are 2 remaining days, right? So we have combination of 2 of them. So Saturday, Sunday, then we have Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, and Friday, Saturday. If you see, each of them are repeating twice. But what do we want? We want only Sundays. So how many possibilities do we have for Sundays? First is this, Saturday, Sunday, and second is this Sunday, Monday. So out of this total 7 cases, we have Saturday, Sunday and Sunday, Monday, which are our favorable cases. We want only Sundays, so we are taking the possibilities of Sunday. So there are 2 possibilities. So the probability for 53 Sundays would be, how many possibilities do we have? 2, right? 2 divided by total possibilities is 7. So that is 2 by 7. Now, we have seen the axioms of probabilities. In that, probability of any two event would be always equal to what? 1. Probability of 52 Sundays plus probability of 53 Sundays will be equal to 1. Probability of 52 Sundays, we have to find that out. Yes. So what we are doing, I'm taking this on the other side of equal to. Probability of 53 Sundays. So when it goes on that side, it becomes 1 minus probability of 53 Sundays. Probability of 53 Sundays we have just now found out as 2 by 7. So just substitute into this 1 minus 2 by 7 and subtract them. Take LCM of them and then 7 minus 2, which is 5 by 7. This is my probability for 52 Sundays. Probability that a leap year can have 52 Sundays. Now let's look into the 7th example. Tickets numbered 1 to 20 are mixed up. There are tickets which has the numbers 1, 2, 3, 4, 5, 6 up to 20. So there are total 20 tickets. They are all mixed up. Let us take a container and all the tickets numbered are all mixed up. Then we are supposed to pick any ticket at random. Randomly, we have to pick up one ticket. What is the probability that the ticket drawn has a number which is multiple of 3 or 5? Alright, let's first of all see the sample space for this experiment. How many possibilities do we have? Total 20 possibilities. There are total 20 tickets. So the possibilities would be total 20. So the number of sample space would be 20. All the tickets have numbered serial wise from 1 till 20. So my sample space would be 1, 2, 3, 4, 5, 6 up to 20. Now let's name this event as A. Event of getting a number which is a multiple of 3 or 5. Out of this 20, we have to find out one number which is not one number. We have to find out any number which is a multiple of 3 or 5. How many numbers would be there? Would be multiple of 3. Multiple of 3 as in those numbers which can be easily divisible by 3. Yes. So if we go 3, 6, 9, 12, 15, 18. Next is 21 also. In the table of 3, if I am going, then 3, 6, 9, 12, 15, 18. Then next we have 21. 21 is not available into the set. Our set is restricted till only 20. So we have till 18 only. Next is multiple of 5. Multiple of 5 would be, if we go in the table of 5, 5, 10, 20. Next is 25, which is not into the set. So only this much. How many possibilities do we have? 9. Right? Number of possibilities is 9 into this. So the probability that the ticket drawn has a number which is a multiple of 3 or 5 would be number of elements present into the set A divided by the sample space. Into that event we have 9 divided by the sample space which is 20. Now let's take this example. In this we have a lottery. In the lottery there are total 10 prizes and 25 blanks. Okay. Suppose I am giving you all of you any lottery. In that lottery, each of you I am giving you one lottery. Out of that lottery, only there are 10 prizes. There are 10 numbers or 10 lotteries such that they will get the prizes. Remaining 25 are blank. They won't get any prize or anything. Those are blank lotteries. Alright. So the sample space would be what? How many total lotteries do we have? 10 for prizes as well as 25 for blanks. So which is 35. This is the number of lotteries. This is the number of lotteries which is my sample space. Prizes as well as the blanks. Now if we are picking up any lottery at random, we have to find out the probability of getting a prize. So the probability of getting a prize will be number of prizes divided by sample space. Number of prizes given to us is what? 10 divided by sample space. We have just seen 35, which is the total number of lotteries, prizes as well as the blank. So that is 10 by 35. After reducing, we get it as 2 by 7. Alright. Now are you all getting clear with the meaning of probability? How you have to solve the probability? Remember first of all this formula for probability and apply accordingly. Let's look into this example. A bag contains 6 black and 8 white balls. There is one bag in that we have all balls mixed up, black balls and white balls. So the total number of black balls is 6 and the total number of white balls we have is 8. Alright. Then how many total number of balls irrespective of their color? We don't have to look at the color. Only balls available into the bag would be addition of the black ball as well as white ball. So which is 6 plus 8. So that is 14. One bag is drawn at random. Out of this 14 balls, we are supposed to be drawing one ball at random. And we have to find out the probability that the one ball which we are drawing is white. We need that ball to be white, no any other color. So the probability that the ball drawn is white would be, the formula would be number of white balls divided by the total number. So number of white balls we have as 8 divided by the total number is 14. Yes. So always remember to do it. Denominator mein we will always have the sample space. Sample space as in the total number of possible outcomes for that experiment. Now let's see this last example. Out of 300 students in a school, 95 play cricket only, 120 play football only, 80 play volleyball only, and 5 play no games. If one student is chosen at random, find the probability that we have to find out 3 probabilities for this example. Now what data is given to you? there is a school and in that we have total 300 students. So the total number of students would be 300. Whatever the data which is given to you in your question, write that down first of all. Next we have 95 play cricket only. Now look clearly at this word which is only. What do we mean by this? 95 play cricket only. There are 95 students who play only cricket, no any other game. What does the only word suggest is that these students, 95 students, play only one game which is cricket. They don't play any another game. Similarly, we have 120 play football only, which means that this 120 student will only play football, no other game. And 80 students will play volleyball only, no any another game. They are not involved into any another game. That is the importance of the word only. And 5 play no games. There are 5 students who play no games. They are not playing cricket, no football, no volleyball. They are just observing, just the observers. They are not playing any games. Alright, so we have written the data over here. Number of students who play cricket, football, volleyball, as well as who plays no games. The first question is, find the probability that the student out of this 300 student, total possibilities is what? The total number of students, which is 300. Out of this 300, we are supposed to be choosing one student at a time. We are choosing one student at a time. We have to find out whether this one student that we are choosing is first plays football, second either cricket or volleyball, third is neither football nor volleyball. Let's go one by one. The first is probability of getting a player who plays volleyball. The formula would be number of students who play the volleyball divided by the sample space, which is total students. There are only 80 students which play the volleyball divided by the total student, which is 300. Alright, reduce this and we get the answer as and 4 by 50. Yes, this is my probability. Similarly, let's look for another question. The probability of getting a player who plays either cricket or volleyball. We have to find out probability of getting a player who plays either cricket or volleyball. Right? Now remember this one thing I told you about addition rule and multiplication rule. What does your addition rule says? Addition rule says if there is a word or in between two events. The first event is student who play cricket or student who play volleyball, right? So we have the word or in between. So what we have to do? Find out the probability of cricket as well as the volleyball, and by addition rule we have to add both of them. So here if we see number of students play cricket or volleyball divided by the total number. For cricket, we have total number is 95 divided by total number 300. Or the word or is being used. So by addition rule, we have plus. Next is volleyball. For volleyball, students are 80 divided by total. So if we add them, the denominators are same, add the numerators. So that is 175 by 300, which is 7 by 12. So this is my answer for the second one. Yes, getting the difference between addition rule as well as the multiplication rule. Now, the third question into this example is the probability of getting a player who plays neither football nor volleyball. We have to find out one player. How many games do we have? One is football. The next we have is volleyball. Then we have cricket. And also, if you know, we have students who play no games at all. So the question is probability of getting a player who plays neither football nor volleyball. I don't want the students playing football as well as volleyball, which means we want only those students who plays the cricket or the students who play no games at all. Getting the difference between both of them? Probability of getting a player who plays neither football nor volleyball. There are total 4 possibilities. Out of them, 2 are cancelled out, remaining are 2. So we have to find out probabilities for both of them. Probability of getting a player who plays cricket or no games at all. Alright, so that is number of students. Formula में substitute करके we have number of students play cricket or no game divided by the total students. For cricket we have 95 divided by the total 300 plus students who play no game is 5 by 300. Denominators are same, so we can add the numerators. So which is 1 by 3 is the answer to this probability. I hope these examples are clear to everyone. Go through them and try to solve them on your own.